Hello class, welcome to the next lesson in 8th grade Eureka Math. We're working in Module 4, Lesson 23 today. Lesson 23 is called the Defining Equation of a Line. So we are going to talk about equations of lines today, which we've been talking about a lot, but there's a little idea that we want to share with you today. If you follow along, it should be it's not a difficult concept, might be a little bit tricky, but you can figure it out. Just pay attention, work hard, do your best. You shouldn't have any problems. You will need pages 281 through 293 in your Module 4 workbook, so grab those now. Also grab some pages for your notes so you can take some notes with me. Just as a reminder, like I do at the beginning of every video, remember that you are in control of the speed of this lesson. If you think you understand it, go ahead and move on, move ahead. If you need to go back and rewatch anything, you can pause a video to go back, rewatch something. You can also pause the video anytime you want to get caught up on any notes. So if I'm going a little bit too fast, feel free to pause the video, write down what you need to write down, and then keep the video going so that you can hear what I say. Writing down and listening are both important, but luckily you can just pause the video to write stuff down and then start the video again when you are ready to listen. So remember, you are in control. Do what you have to do to succeed. And again, if you have any questions about anything in this lesson, remember to reach out and ask me, talk to me about it. I will help you in any way I can, however I can, whenever I can. You just have to ask so that you can do your best. Okay, with those preliminaries out of the way, let's get started talking about the vocabulary for this lesson. We have 3 vocabulary terms for this lesson: standard form, slope-intercept form, and equivalent fractions/ratios. So we've seen standard form and slope-intercept form before, so you should be pretty familiar with those. Standard form and slope-intercept form are both ways to write a linear equation. They are both ways to write a linear equation. Standard form is ax plus by equals c. X and y are the variables. A, b, and c are just numbers. X and y are the variables. A, b, c are numbers. You've seen standard form before. You've worked with standard form before. You should recognize it. Slope-intercept form is just a different way to write an equation. In slope-intercept form, we have y equals mx plus b. Y and x are variables. M is the slope. B is the y-intercept. That's why we call it slope-intercept form. You should be familiar with both of those types of forms. You should know how to write them, and you should be able to use your properties to go back and forth. Use your properties to change standard into slope-intercept, and use other properties to change slope-intercept to standard. You should be able to know these, recognize these, and trade back and forth. Our third term, equivalent fractions, or we can also say equivalent ratios. These are more than one fraction, so these are fractions with an S, that simplify to be equal to each other. So these are fractions that simplify to be equal. So these are the same fraction, they just look different, but it's obvious that they are the same after you simplify. So we're going to use all 3 of these words today. Let's talk about what we're doing today. Today, we will show how many linear equations that look different can still represent the same line. So what we're going to see today is we're going to see linear equations that might look different. Maybe they might be written in different forms, like they might be written in, one might be written in standard form, one might be written in slope-intercept form. They might be written in different kinds of standard form. But what they really are is they represent the same line. Sometimes equations, even if they look different, are for the same line. They look different, but they are the same line. And we're going to see that today. I do have a couple examples for us to look at while we think about this idea. Here's an example of equations that look different, but can still be the same line. So for example, this example A, I start with 2x plus 2y equals 4. 2x plus 2y equals 4. If I multiply everything times 3, I multiply every term by 3. I do 3 times the 2x, 3 times the 2y, and 3 times the 4. I get 6x plus 6y equals 12. So the equation I started with, 2x plus 2y equals 4, and the equation I finish with, 6x plus 6y equals 12, those actually make, if you graph them, they will make the same line. They look different, but they make the same line. And the reason they make the same line is because I multiplied everything by 3. I multiplied everything by 3. So the ratio stayed the same. I changed everything by the same amount. So these look different, but they're the same line because I changed everything the same way. Next example I had to do on a different page, so you might need a second page for example B. But here's example B. Example B is kind of an example of how do you check to see if equations are the same line. So right here I have two equations. 16x plus 24y equals 40. That's in standard form. And I have 2x plus 3y equals 5. Two equations that look different. But are they the same line? These equations look different, but are they the same line? Well, to check, to test this, we look at the constants and the coefficients. So I take the 16, the 24, and the 40, 16, 24, and 40. And I take the matching coefficients, the 2, the 3, and the 5, and I make fractions. The 16 and the 2 go together. The 24 and the 3 go together. The 40 and the 5 go together. Now I had three fractions, 16 over 2, 24 over 3, and 40 over 5. Now when I simplify the fractions, I should write that, fractions and simplify. 16 divided by 2 makes 8. 24 divided by 3 makes 8. 40 divided by 5 makes 8. 8 equals 8 equals 8. This ratio is 8. This ratio is 8. This ratio is 8. So 16 and 2, 24 over 3, 40 over 5 are all equivalent fractions. So we have three equivalent fractions. All three are equivalent. All three are equal, which means the equations represent the same line. That's how you check. You take both equations, you build fractions of the matching pieces. If the fractions are equivalent, all three fractions have to be equivalent. Same ratio every time. If all three are the same, then the equations represent the same line. So these, if I graph this equation and I graph this equation, I will get the same line because the pieces are changed by the same ratio. That's the way to test. That's what we're doing today. If you got that, you're golden. You know exactly what we're doing. If you understood that perfectly, excellent. But we do have some exercises, a little bit exploratory activity to help you understand it further. So let's move on toward, let's start the first page of our lesson, page 281, which looks like this. That's in front of you right now. Exploratory challenges and exercises 1, 2, and 3. So we have 3 exercises that we are going to work on today. 3 exercises where we're going to test this to see if it works. So, 1, sketch the graph of the equation 9x plus 3y using intercepts. Then answer parts A through F that follow. So I need to graph this using intercepts. Now remember, using intercepts is when they cross the x and y axis. That's what intercept means. So we had to figure out what is the point when x equals 0? And what is the coordinates when y equals 0? That's what graphing with intercepts means. So when x is 0, we get 9 times 0 plus 3y equals 18. That's 0 plus 3y equals 18. That's 3y equals 18. That's y equals 6. So the first intercept is 0, 6. That's where it crosses the x-axis. Now we need to figure out where it crosses the y-axis. So y is 0. So we get 9x plus 3 times 0 equals 18. That's 9x plus 0 equals 18. That's 9x equals 18, which means x is 2. So the second intercept is 2, 0. Now I have my intercepts. I need to graph them. So let me get my graph paper. Let's label this our exercises. And we are on exercise 1. So I need to graph intercepts 0, 6 and 2, 0. So let's do it this way. I'm going to go up about that many. I'm going to go right about that many because all my coordinates are positive, so this should work. Here's my y-axis. Here's my x-axis. There's the origin 0, 0. Let me label my intervals. Might have gone a little bit too far on the x-axis, but that doesn't hurt anything. There we go. Okay, so now let me graph my coordinates. I have 0, 6. So 0 on the x, 6 on the y, which is right here. And I have 2, 0, 2x, and 0y right there. And when those are my intercepts. Now to make my line, I just play every kid's favorite game. Connect the dots. Connect the points. And that is the graph of my line. There we go. So I did that first part. I graphed using intercepts. Part A now, I need to sketch the graph of this equation on the same coordinate plane. So this is in slope-intercept form. So let's B in this. Remember, slope-intercept is y equals mx plus b. So b equals 6. So the y-intercept is 0, 6. Good enough. M, my slope rule, is -3, which means up -3, right 1. So let's graph using this. So I need my y-intercept, which is 0, 6. So on the same graph, I do 0x and 6y, so it's going to be right there. And now I need to follow my slope rule, up -3, which means down 3, remember, right 1. So -3, 1, 2, 3, -3, right 1. So this is my other point. Now to graph them, I'm going to connect the dots. But you already see what's going to happen. I just made the same line. So instead of a red line, instead of a blue line, I now have a purple line because it was the same line. So what do you notice about these graphs? What do we notice? I notice they're the same line. And why do you think this is so? They were just written in different forms. They were just written in different forms. One was standard form, one was slope-intercept form, but they are the same line. You can see that because I graphed it, and it's the same exact line. Very good. Okay, so now let's see here. Rewrite our slope-intercept form in standard form. So I need to use my properties to change slope-intercept into standard. So remember our rules for standard form. A is not negative. That's one rule. Rule 2, we have no fractions. We have integers only. We need integers. And rule 3, standard form is ax plus by equals c. So those are the 3 rules we have for writing in standard form. So let's write this in standard form. Y equals negative 3x plus 6. Well, the first thing I need to do is x has to be a. Remember, a is connected with x. This is negative. I can't have it negative. So let me add 3x to both sides with the addition property of equality. That gives me 3x plus y equals 6. 3x plus y equals 6. So that, let's check up with standard form. Is a not negative? Well, 3 is not negative. Good. Do we have only integers? No fractions? Yep, no fractions. Check. So check, check. And does it look like this? Ax plus by equals c? Yep, it does, because a is 3, b is 1, c is 6. So check. So that is in standard form. There we go. Now, here we go. We need to identify the constants a, b, and c that we had. So I just said it out loud, but I guess I can write it down. A is 3. B is 1, because 1y is just y. And c is 6. So we have 3, 1, 6. A is 3, b is 1, c is 6. So far, if you do step by step and do what they tell you to, this is making sense. Let's look at part E on the next page. Identify the constants in the equation 9x plus 3y equals 18, which is what we started with. 9x plus 3y equals 18 back in the beginning of the question. So they want us to find these constants. So in standard form, ax, so we got 9 is a, by, b is 3, equals c, which is 18. Excuse me. So a is 9, b is 3, c is 18. Okay, we found those constants. What do they want us to do with them in part F? What do you notice about a, oh, I'm sorry, I'm supposed to label them a prime, b prime, c prime. There we go. Okay. So what do we notice about a prime divided by a? So let's look at these right here. Let's get those right there so you can see that. We have a, b, c. From the equation in part C, we have a prime, b prime, c prime. What do you notice about these? Well, a prime is 9, b prime is 3, c prime is 18. Remember, I'm making fractions. And if I go back here, a was 3, b was 1, and c was 6. What do we notice about these? What do we notice? Well, let's simplify our fractions. 9 divided by 3 is 3. 3 divided by 1 is 3. 18 divided by 6 is 3. 3, 3, 3. 3 equals 3 equals 3. So what do we notice? Same fraction, different forms. They just look different, which means that's another piece of evidence. If we go back to our notes, remember right here, I told you equivalent fractions mean they are the same line. Equivalent fractions means same line. So we have equivalent fractions in part F, and on our graph, we had the same line. Equivalent fractions, 3 equals 3 equals 3, same line on the graph, which means the first equation we had, 9x plus 3y equals 18, and the slope-intercept form, y equals negative 3x plus 6, they are the same equation. These are the same line, and we proved it two different ways. We proved it by graphing, and we proved it with finding the equivalent fractions when we changed both into standard form. We had to change the slope-intercept into standard. Sorry, we changed slope-intercept into standard, and then when we had two standard forms, we looked at the fraction ratios. They're the same, so we know they're the same line. That's great. We did that. We did it. That's what we're doing today. We are identifying when a line can have more than one equation. So we're finding lines that have more than one equation today. That is what we are doing. Let's test this idea again with exercise 2. Exercise 2, let's see what they want us to do. Sketch the graph of the equation 1/2 x plus 3 using the y-intercept point and the slope. So we need to make another graph. Let's do another graph. Let's do exercise 2. And we need to graph 1/2 x plus 3. Okay, so let's do... We could do this. Yeah, why not? We'll do that way. And we'll do that much, I guess. I don't know. We'll see. I think it'll work. I drew my axes. I labeled my axes. I'm labeling my intervals right now. Okay, so we need to graph. Let me write down the equation on the graph. I need to graph y equals 1/2 x plus 3. 1/2 x plus 3. Okay, so let me graph this. To graph this, I need to know the y-intercept. So b is 3, which means the intercept point is 0, 3. M is 1/2, which means I go up 1, right 2. So that's my slope rule. So let's start with the y-intercept at 0, 3. So 0, 3, that's the y-intercept right there. Slope rule, up 1, right 2. So my next point goes right there. And to make my line, I connect my 2 points. So let me connect it right like that. There we go. That is my graph. Done. I did that first part of number 2. Let's see what they want me to do next after I did my graph. So let's see, it said sketch the graph using y-intercept and slope, then answers part A through F. So now part A, I have another equation. Sketch this equation using intercepts. And remember, intercepts is when x is 0 and when y is 0. So let's find my coordinates with the intercepts. So I have 4 times 0 minus 8y equals negative 24. That's 0 minus 8y equals negative 24. That's negative 8y equals negative 24. So y has to be 3. Y has to be 3. Because negative 24 divided by negative 8 is 3. So my x-intercept is 0, 3. For the y-intercept, I get 4x minus 8 times 0 equals negative 24. That gives me 4x minus 0 equals negative 24. That's 4x equals negative 24. Divide both sides by 4. Negative 24 is negative 6. So my x-intercept is negative 6, 0. Now I need to graph these. So 0 and 3. 0 and 3. Oh, look at that. Same spot. Negative 6 and 0. Oh, it's over here. Negative 6 and 0. I did not make, it turns out I did not make my axes long enough when I started. Negative 5, negative 6. There we go. Now you can see I have 0, 0 and 3, and negative 6 and 0. Those are my intercepts. I connect them to make my graph, and you're going to notice something. Well, you would notice it if I did a better job of drawing my green line, but let me draw my first one again, because what you should notice, I believe, is that they are the same, but we'll see. Let's just leave it like that. Maybe they look like they might be pretty close. Now, maybe they're the same line. Maybe they are a little bit different. It could just be that I was not as precise as possible. But luckily for us, there is another way to check if they are the same. So maybe this equation and this equation are the same line. Maybe. Our graph looks like it might be close. It could be possible. Maybe I was not as precise as I should have been when I was graphing. Maybe, but maybe not. Maybe they're not the same. They just look pretty close. Let's check the way we did in exercise 1 to see if they're the same line by looking at the ratio, looking at the fractions again. So we need both standard form, and we need to look at the fractions. So our graph could be the same, could be different. It really comes down to how precise you are. So maybe I made a mistake and they should line up perfectly. Let's check. What do you notice about these graphs? Well, looking at my graph, I'm thinking maybe I did not line up my points for my green line as precisely. I think one of the reasons is because I'm trying to make the points bigger so that you can see them on the camera. Because if I do it that way, then it looks more precise. I don't know. So it's hard to tell because I'm not being precise, and that's my fault. But let's say, what do you notice about these graphs? They could be, I'm not going to write they are, but they could be the same line. They could be. Let's confirm. Let's check using math, not just graphing, because sometimes I'm a little bit sloppy. But let's confirm by doing the same pattern we did in exercise 1. So we need to rewrite this in standard form. So we have y equals 1/2 x plus 3. And remember our rules for standard form. A is not negative. Integers only. And standard form is ax plus by equals c. So those are our 3 rules. Right now you can see, okay, we already have a fraction, so we already broke rule 2. So what we're going to do is we're going to multiply everything by 2. If we multiply everything by 2, we'll get 2 times y is 2y. 2 times 1/2 is just 1, so we get 1x. And 2 times 3 is 6. So integers only, check. Next step, we want x to be positive. We want the a to be positive, so we cannot move this. It's positive right now, so we cannot move it. So we have to move, but the c, 6 is c, 6 cannot be next to the x, because x has to be on this side, so it has to be on this side. So let's move the 6 away, and we will get 2y minus 6 equals x. And we still need to move the y away, so let's do minus 2y on both sides. So now we have negative 6 equals x minus 2y, which that is standard form. So let's check our rules. A is not negative. Well, 1 is not negative. Integers only, all integers. Ax plus by equals c. I can write it in that form, x minus 2y equals negative 6. Check. This is in standard form. that is in standard form. So we're good. Find the constants. Find the constants coefficients. So from part C, what's A, B, and C? So we need A, we need B, and we need C from what we just did. So in this equation right here, the one circled right here, A is 1 because it's 1x. B is -2 because it's -2y. And C is -6. Done with part D. Part E, identify the constants in this equation. So we need to find A prime, B prime, and C prime. A prime is 4, B prime is -8, C prime is -24. And then what do we notice when we compare the fractions of both constants? So we have A prime is 4 over A, which is 1. B prime is -8 over B, which is -2. C prime is -24 over C, which is -6. What do we notice about these? Well, let's simplify to see what we notice. 4 divided by 1 is 4. -8 divided by -2 is 4. -24 divided by -6 is also 4. So we get 4 equals 4 equals 4. So we have equivalent fractions. Equivalent fractions. Which means, again, just like in our notes, let me find that page. Equivalent fractions, so they're the same line. So it turns out that my graphing was flawed. I did not line up my points very well with my ruler. I need to improve my ruler work because the orange and the green line are the same line. That's just a lesson to me. Mr. Baylor, do better with your ruler work. Because the math, the equivalent fractions prove that these are the same lines, which means if the graph is bad, it's my own fault. I make mistakes. I'm okay with it, but that's why I know my math, so I can check my mistakes and I can fix them. I can do better next time. And guess what? It's next time because we have our third exercise that we need to work on. So let's look at exercise 3. This one, they tell us. They already told us, so they made it easy for us right now. These equations are the same line. They told us straight out they're the same line. Okay, I'm pretty sure that them telling us, now they just want us to prove it. So they told us it's the same line, now they want us to prove it. So this is going to be the same way that we were doing it before, except for no graphing for exercise 3. So what I'd like you to do right now is I want you to pause your video, try number 3 on yourself, by yourself, and see if you can prove that these are the same line. So you're going to write the first one in standard form. You're going to look at the constants, and build your fractions and see if they're equivalent. So see if you can prove what they said on your own. Pause the video, do it yourself. Unpause the video when you're ready to check your answers with mine. Okay, so hopefully you did number 3. Let's check and see how you did. So the first thing we need to do is we need to write this in standard form. And again, our rules for standard form. 1, integers only. I don't have these in any order. I think I'm doing a different order every time I write them. Integers only. A is not negative. And the third rule, standard form, has to be ax plus by equals c. So integers only, A is not negative, and it needs to be written in the standard form way. Already you see that we broke rule 1 over here. We have a fraction. So let's multiply everything by 3 to make the fraction go away. 3 times y is 3y. 2/3 times 3 is 2, so we get 2x. -4 times 3 is -12. So far, so good. Now we have integers only. Great, no more fractions. A is not negative. Well, A x around so it looks like this. So I need to get the C away from AX, so add 12 to both sides. That gives me 3y plus 12 equals 2x. And the y needs to be with the y term needs to be with the x term, so I need to take the 3y over here, do minus 3y over there. 3y minus 3y is 0, so I just get 12. And 2x minus 3y is 2x minus 3y. And that is standard form. Although I can trade the sides. It doesn't make a difference. But I can trade it to look more like that to make it look like proper standard form. So that's standard form right there. So I start with these two equations. I change this one into standard form. And now they want me to find my constants. I need to find A, I need to find B, I need to find C. So A, well, A is with X, so A is 2. B is negative 3, because that's what goes with the Y. And C is 12. There we go. Next step, identify the constants in this equation. And C prime. Well, A prime, it goes with X, so that's 6. B is 36. So we have my constants for the this equation I made. So I have my constants for both equations after they were both in standard form. B prime was negative 9, and B negative 3 is 12. Let me simplify these fractions. Simplify them. $60 is 3 because they're both negative, so it's positive. 36 divided by 12 is 3. So what do I notice? I notice that 3 equals 3 equals 3. So I notice that they are equivalent ratios or equivalent fractions, whatever you want to say, which is our proof. So they told us at the beginning that these equations are the same line. And then we used some math to prove it. We did not have to graph them. We could just did the math. So we missed out on the graphing fun, but we'll be okay. So that is what we're doing today. That is the work. That is the exercises. I think there's a few more exercises we want to do just for a little bit more practice. Let's take a look. Oh, there's a part E. I didn't notice this. You should have noticed that each fraction was equal to the same constant. So they're all equal, which is what we did notice. The fractions are equal. Multiply that constant by the standard form of the equation from part A. Okay, so they want us to take part A and multiply by the 3 we got. So we take this equals 12, and they want us to multiply that equation by the 3 that we found in part D. So we took the equation we made in part A, multiplied by the 3 we found in part D. Okay, well, we need to pass it to all the terms. So 3 times 2x is 6x. 3 times negative 3 is negative 9y. And 3 times 12 is 36. Multiplying by 3, not too tough. What do we notice? Because that's the next question. What do we notice? Well, if you look, you should notice that, let me try to get it on the same page. Look at that, 6x minus 9y equals 36. 6x minus 9y equals 36. So let me show you what we did. In part A, we changed this equation into this equation. And then we multiplied by the 3 in part D And we got the other equation. So we notice same as other equation in the problem. It's the same as the other equation in the problem. So you can see how you can go back and forth. You can see how you can find if two equations are the same line. You can do all of this to find if two equations are the same line. Very useful tools, very useful to be able to do the math and prove if you're talking about the same relationship, the same line. So hopefully you understood all that. Hopefully you got it. Let's check. Let's look at number 4, 5, 6, 7, and 8. There's a few more exercises. Number 4 says, write 3 equations whose graphs are the same line as this equation. So we have this equation. So this is kind of working backwards. Instead of checking to see if two equations are the same, they want you to make equations that are the same. They want you to make equations that are the same. And so hopefully from exercise 3 part E, you saw that all you have to do is multiply everything by the same. Multiply everything by the same. So if this is my starting equation, and I want to make the same, if I want to make something that's the same, then all I need to do is I need to multiply everything by the same thing. So let's just do multiply by, I need 3 equations. So multiply by 2, multiply by 3, multiply by 4. If I multiply everything by 2, 3 times 2 is 3x times 2 is 6x, 2y times 2 is 4y, 7 times 2 is 14. And these are the same. If I multiply everything by 3, 3x times 3 is 9x, 2y times 3 is 6y, 7 times 3 is 21. If I multiply everything by 4, 3x times 4 is 12x, 2y times 4 is 8y, 7 times 4 is 28. And guess what? Are the same line, because all I did is I multiplied. And I proved already in my first 3 exercises that that's how it works. I can just find 3 lines. Same thing for exercise 5. Three equations whose graphs are the same line. 3 equations whose graphs are the same. So if you want, you can just do this the same. You get x minus 9y equals 3/4. And you can just build the chart and pick what you want to multiply by. Now, I'm not going to do all of these for you because it's different for everybody, because you can pick whatever you want to multiply by. Like if it's me, I might multiply by 4, I might multiply by 8, I might multiply by 12 to make the fraction go away. So if you're like me and you did this, you might do 1x times 4 is 4x, negative 9 times 4 is negative 36 in the y, 3/4 times 4 is 3. Then you can multiply by 8, and it gets bigger, and you get 6, because the 8 cancels out the fraction. You get 12x minus 3 is me. You might have different ones, because if you pick something different, your answer is going to be different. But we can have really infinite. We can pick whatever we want on this. Let's see what they want us to do for number 6. For number 6, they're going to want write 3. Oh, same thing. So I'm going to let you do number 6 however you want. You can pick whatever 3 you want for number 6. I'm not going. We can just skip it right now, and you can pick whatever 3 you want. Really does not matter to me what you choose, because whatever you choose, to multiply by, as long as you multiply everything by the same thing, you're going to get all same line. Whatever, as long as you are solid with your multiplication, as long as you are consistent, you should get the same line. Number 7 is the fun one. Write at least 2 equations in the form ax plus by equals c whose graphs are on the line shown below. So the first thing you need to do with this one is actually find the equation for this line. Find the equation for this line is the first thing you need to do. So how do you know what this line is? Well, what I would do to find the equation of this line is you're going to have to use the point slope method. Because if you look, the y-intercept is not exact. So you need to find 2 points right there. A and B. A is -1, -1. And B is 3x on 0y. Then you need to find the slope of this, which is y2 minus y1 over x2 minus x1. Let's just do x1, y1, x2, y2. So y2 is 0 minus y1, which is -1, divided by 3 minus -1. That turns into 0 plus 1 and 3 plus 1. So your slope is 1/4. And then you get y equals mx plus b. Remember, we did this before a couple lessons ago, so this is testing your skills with writing equations. This is testing your skills to write equations. Hopefully you're getting it. Hopefully this looks familiar. Y, I'm going to pick this for my x and y. So y is 0, m is 1/4, x is 3, and then this, substituting this x and y and the m will find b for me. So I get 0 equals 3/4 plus b. I do minus 3/4 on both sides, so I get -3/4 equals b. So now I have m and b. So this line, a lot of work to find the equation for this line, but we know how to do it because we did it a few lessons ago. Y equals m x and b. So this is my equation for the line, but I'm not done yet because I need to get this in standard form so I can find other equations. So now I need to take y equals 1/4 x minus 3/4 and change it to standard form. So I'm going to start by multiplying everything by 4 so that I have integers only. 4y equals x minus 3. I need to add 3 to both sides. So I get 4y plus 3 equals x. Then I need to do minus 4y to both sides. So I get 3 equals x minus 4y. And in standard form, that's x minus 4y equals 3. Whoa, now I'm almost ready to answer the question. Question 7 said 2 equations whose graphs are the line shown below. So I had to use point slope method, which we did in another lesson. I found the equation in slope intercept form. My green work is the slope intercept, but they want it in standard form. So I had to change my slope intercept into standard form. So I used two points and point slope to find slope intercept. Then I changed slope intercept to standard. But then they want another one because they said they want, they want 2 equations. So here's one. To find another one, my other answer, I'm just going to multiply everything by 2. Because remember, that's what we learned in this lesson. So x times 2 is 2x. -4y times 2 is -8y. And 3 times 2 is 6. So these are my answers. The first thing I had to do was write the equation. And I had to use the point slope method we learned in another lesson. Then I had to change the slope intercept into standard. Then I had to find an equivalent one using today's method. Quite a bit of work for number 7, but it was kind of fun. I enjoyed it. So that's our exercises today. Really, the big ideas were in exercises 1, 2, and 3. If you understood exercises 1, 2, and 3, you're good. You don't need to worry about anything. You're great. Exercises 1, 2, and 3 were amazing for the lesson today. Let's look and see what you're going to be working on independently today. Oh, there's an 8th one. You know what? We're just going to skip number 8. Number 8, you can do on your own. If you like, it's the exact same thing as number 7. I completely forgot there was an exercise 8. We're going to skip number 8 in the video, but you can do it on your own. And my answers for number 8, I will do it later, and my answers will be on the Google Classroom answer sheet. So you can check your answers with number 8 if you want to. But to save time in this video, I'm just going to say skip number. I'm not going to do number 8 for you. You can do it yourself, and you can check your answers online to make sure you know what you're doing. After you're good with the exercise and you finish the exercise and you feel comfortable with all that, let's talk. You're going to do some independent work. So let's talk about the independent work that you're going to do today. Here's the lesson summary on page 287, just talking about how if all of these are equal, then they are the same line, which is what we talked about in the exercise 1, 2, and 3. Page 289 is the exit ticket, which we'll talk about last. Page 291 and 292 are your homework helper if you want some more examples where they give you the question, they give you the answer, and they tell you what they were thinking. Homework helper is great if you need a little bit more guidance. Questions on the problem set. Number 4 and 5 are challenge problems, so try them yourself. But if you are having trouble with them, that's fine. Number 1, so you will have to do some more. You'll have to get some scratch paper to do the same line. Do these make the same line? And then number 3, write an equation that will give you that is the same line. It does not hurt. Remember, if you have any questions, you have to reach out and ask. Remember to check your answers for the online. When you feel confident that you know what you're doing and you feel comfortable with this math and you've asked me all of your questions, then you can work on the exit ticket back on page 289. There are 2 questions on the exit ticket. They're asking you, do these equations make the same line? Why or why not? So you need to tell me yes or no and make sure you have proof. I need to see your work and see the evidence. And then they give you an equation. They want you to make another equation with the same line and explain how you know your equation has the same line as this one. So that's your 2 questions on the exit ticket. Remember to ask me for help if you're struggling, if you need more guidance, or even if you just want me to check your work, you just have to ask. When you're done with this exit ticket, make sure you take a picture of it and turn it into the Google Classroom so that I can see that you understand this lesson. But other than that, have a great time. Good luck. Have fun. Work hard.